Hello. So, today we will go through some workout example. In last lecture we have discussed how to calculate the net area of a member along critical section. So, with the use of this formula we will today try to find out the net area of the section for a given problem. So, first problem is this one, that is calculate the net area of an angle ISA 75 by 75 by 6, which is connected to the gusset plate through single leg as shown in the following figure, and bolts are used of M20 grade of 4.6. So, to start with, we can see that first case we can consider that a gusset plate is connected with an angle section of ISA 75 by 75 by 6 with a bolt, right. So, this member size is ISA 75 by 75 by 6, and this is gusset plate, and this bolt is M20 grade of bolt with 4.6 grade. So, this is one case, and again this is bolt connection. Again same angle if it is connected by weld. So, in this case how the net area is going to be affected, that we will try to find out. So, this is weld connection in this area, right. So, this angle section is also ISA 75 by 75 by 6. So, for first case if we try to find out, then diameter of bolt hole DH I can find out, nominal diameter of bolt plus clearance 2 mm. So, this is 22 mm. So, net area of the connected leg, net area of connected leg we can find out, and the unconnected leg we can find out, and then we can add it. So, net area of the connected leg ANC will become, this will be ANC will be 75 minus 6 by 2 minus 22. Why 6 by 2 into T? Because when we are going to calculate the net area of a leg, we can calculate that, means assuming that this is one part. If I consider this is one part, this 75 by 75, and this is another part. So, area will be 75 into 6. Again for this leg area will be 75 into 6, but if you see that as 75 is from root to toe, that means we are adding twice this part. So, to take it actual value, we are going to reduce half of the things in this part and half of the area in this part. Therefore, we have reduced 6 by 2, not 6 into 6, 6 by 2 into 6. So, the area will become, because this area will become 6 into 6, and that means 36, that means 18 will be going to here and 18 will be going to here. Therefore, the ANC value will become after calculation it will be 300 millimeter square. right, 300 millimeter square. Similarly, the gross area of the outstanding leg, I can find out gross area of the outstanding leg. That will be AGO, gross area of the outstanding leg. That will be simply 75 minus 6 by 2 into 6. So, this will be 432 millimeter square. So, net area AN, net area of the angle will be ANC plus AGO is equal to 300 plus 432 is equal to 732 millimeter square. So, this is how I can find out the net area of the angle section, right. That means, when I am going to find out the net area of the angle section, I am going to reduce the whole area due to presence of bolt. Now, in this case one bolt was present, so in one leg, so we have reduced the whole area of one bolt, right. So, now in case of weld connection there is no reduction. So, I can find out simply the area, that is for weld connection I can find out the net area of the connected leg, that will be simply 75 minus 6 by 2 into 6, that will be 432 millimeter square, and AGO, the gross area of the outstanding leg, will also be same, because due to weld connection there will be no hole in the angle section, therefore, there will be no reduction. So, this will become also 432 millimeter square. So, net area of the angle in this case will be ANC plus AGO is equal to 432 into 4 plus 432, that means 864 millimeter square. So, here what we could see, that net area of the weld connection is becoming 864 millimeter square. So, if we compare that for weld connection the net area is 864 and weld net area for bolt connection is 732. That means, the strength of the member or the angle is going to be reduced if we use bolt connection compared to the weld connection, because of the insertion of the hole, the reduction in strength will happen, as the hole cannot take tension, means that area cannot take tension. That is why the effective area for taking the tension will be less, that is 732 millimeter square, right. Now, another problem we will go through, that is a comparison between chain bolting and zigzag bolting. This is the problem. Say a flat size of 200 by 8 mm of grade Fe 410 is used as tension member in a root truss. It is connected to a 12 mm gusset plate by M16 bolt, that means 16 mm diameter bolt of grade 4.6 using two alternate methods of bolting as shown in the following figure. Calculate the net area of the member. So, what we could say, that in case of chain bolting, say first we will consider the chain bolting. These connections are given here. If we see here that the edge distance is 50 and pitch is, means this distance is 100 and again 50, right, and this pitch distance along horizontal is 75, 75, 75, 75, right. And in case of plain bolting or chain bolting, it will be means the failure may happen in this direction, means 1, 2, 3, 4. It is a simple way the failure will happen. So, we have to calculate the net area along this line. So, for chain bolting we can find out the net area along line 1, 2, 3, 4. That will be simply A n is equal to 200 minus 2 into 18. Here nominal diameter of the bolt is 16. So, bolt hole will become DH will become 16 plus 2, that is 18 mm, right. So, the along this line 1, 2, 3, 4, 2 bolts are there, therefore, the reduction will be 200 minus 2 into bolt hole, bolt diameter into the thickness. Thickness was given as 8 mm. So, after calculating we can find out this is 1312 millimeter square. So, for chain bolting the net area will be this. So, from this net area I can finally find out the rupture strength, means what will be the strength of the strength of the plate that can be found, right. AgFy sorry not AgFy 0.9 AnFu by gamma n. So, from that I can find out. So, that formula will come later, how to find out the strength due to rupture, that I will come later, how to find out. So, when we are going to find out the strength, we need to know the what is the net area. So, that net area we are calculating. So, now second case I will come, that is zigzag bolting. In case of zigzag bolting there are several options in which it may fail. So, we have to be careful. One is you see that in line 1, 2, 3 it may fail, line 1, 2, 3 it may fail. Then it may fail 4, 5, 6, 7, but if it has to fail 4, 5, 6, 7, also bolt 2 has to fail, this is one case. Another case is it can fail that 4, 5, 2, 3, again 4, 5 sorry 1, 5, 2, 3 and again 1, 5, 6, 7. So, there are several options are there. So, if we write down one by one option, one will be 1, 2, 3, another will be 4, 5, 2, 3, 4, 5, 2, 6, 7 and 4, 5, 6, 7. So, I have to calculate the net area along these 4 direction, 4 path, right, and the minimum one will be the net area of the plate. So, first we will consider 1, 2, 3. So, along 1, 2, 3. So, along 1, 2, 3 means this one 1, 2, 3. So, here what we could see, it is a simple one that only one bolt is coming into picture. So, net area we can find out, that will be B minus n into dH into T, that will be 200 minus 18 into 1 into 8, thickness is 8. So, I can find out that is 1456 millimeter square. So, net area along 1, 2, 3 we can find out in this way, right. Now, we will find out the net area along 4, 5, 2, 3, along 4, 5, 2, 3, right. So, net area along 4, 5, 2, 3 I can find out. So, 4, 5, 2, 3 means this 4, 5, 2, 3, that means one stagger piece is there. So, if I calculate A n, this will be B minus n dH plus n into dH n into dH plus psi square by 4 g I. Here I is equal to 1 into t. So, if I calculate this, if I put the value B is 200 minus n will be 2, because it crosses 2 volt 5 and 2, right. So, 2 into 18 plus only one inclined length is there. So, that I have to find out. So, psi will be here 75 and g will be 4 in g will be 50. So, g is given here, this is 50, right. So, this is 50 and this value is 75. So, this is how I can find out the value. T is 8. So, after calculation we can find out the 1537 millimeter square. So, net area along 4523 is coming 1537. Again net area along 45267. 45267. 45267 means this will be 45267. That means 3 bolts are there. So, here I can find out net area will be B is 200 minus n will be 3 into DH is 18 plus here 2 numbers of inclined length is there. So, 2 into psi, psi value will be 75 and 4 g 50 into t. So, I can find out this value as 1618 millimeter square. That means, here you see though the number of bolts are increasing, but due to staggered pitch some area is going to be added. So, though we are deducting 3 into 18, but we are adding this. Therefore, the net area you see, if you compare with this 4523, net area is becoming more. That means, failure along this direction chances is less. Chances of failure along 45267 is less compared to this. However, we have to see the least one. Now, another scope is that 4567. Now, 4567 means this way. Now, if the plate has to fail along 4567, then first it has to fail this due to shear. The bolt 2 has to fail. That means, when we will be going to calculate the strength along this direction, we have to add strength of 2. That means, it will be more than the earlier cases. Therefore, we are not going to calculate this, because we know it will be more, strength will be more. So, we are not going to calculate. So, what we could see, the net sectional area we are getting minimum of one we got 1456, then we get 1537 and then 1618. So, minimum of this, that means 1456, and 1456 happened in case of failure of 1 2 3. That means, when the failure is means we are considering this direction, it may fail, right. So, along 1 2 3, sorry this one, along 1 2 3 it will fail, means under this geometrical condition and configuration, the critical section will be 1, 2, 3 along 1, 2, 3, and this critical section the net area we are going to get as 1, 4, 5, 6, right. And if you remember that if we consider, means here the critical sectional area we are getting 1, 4, 5, 6, 1, 4, 5, 6 millimeter square, and for this we are going to find out the net area as 1, 3, 1, 2, right. So, for plain bolting means 6 number of bolt is given here, here also we have given 6 number of bolt, but we are getting less strength in case of plain bolting compared to the zigzag bolting. That means, we should go for zigzag bolting as much as possible. That means, the efficiency of the bolting connections will be more in case of zigzag bolting compared to the chain bolting, right. So, this is what about the net area calculation. So, if we see the solution, whatever I have discussed I have written here, you can have a look. That is, the for plain bolting we have A and C, we can find out, sorry, not this one, after this we have this slide. So, if we go the solution, we will see for chain bolting the net area will be 200 is the width minus the whole area into thickness. So, 1312, right. So, for chain bolting the critical sectional area of the plate will become 1312. Here we have considered 18 because 16 mm diameter has been considered, and so bolt diameter means hole diameter will be 16 plus 2, that is 18 mm. For zigzag bolting, as we have shown that the chances of failure may happen along 1, 2, 3, along 4, 5, 2, 3, along 4, 5, 2, 6, 7 or along 4, 5, 6, 7. Therefore, we have to calculate the all possible cases, and we have to find out the minimum value, right. Now, if we consider the net area along 1, 2, 3, there it will be simply B minus N dH into T, where N is equal to 1 and there is no staggered pitch. Therefore, we got 1, 4, 5, 6 net area along 1, 2, 3. Similarly, if I go next 4, 5, 2, 3, we can find out the net area, that will be B minus N dH plus PSI square by 4 GI into T. Here along 4, 5, 2, 3, 2 bolts are coming into picture. So, the deduction when we are going to do, we are deducting area of the bolt hole of 2 bolt. So, 200 minus 2 into 18, then plus, because of staggered pitch some area will be going to added, which is the amount of PSI square plus by 4 GI. So, here PSI, the staggered pitch we have seen that is 75 mm and gauge was given 50 mm. So, we could find the net area is coming 1537 millimeter square. Then again, if we come to net area calculation along 4, 5, 2, 6, 7, 4, 5, 2, 6, 7, then we can see that net area will become here 200 minus 3 into 18, because 3 number of bolt are coming into picture and 2 number of staggered pitch are coming into picture. So, minus 3 into 18 plus 2 into 75 square by 4 into 50 into 8 thickness. So, this is coming 1618 mm square, and we are not going to calculate along 4, 5, 6, 7, because if it has to fail, first the bolt 1 has to fail. That means, when we will be calculating the failure strength along 4, 5, 6, 7, we have to add the failure strength of the bolt 1. Therefore, this will be higher than the earlier one, that is why we are not going to calculate. So, the sectional area, that means the critical sectional area will become the minimum of these 3 cases, okay, and minimum of these 3 cases will be coming as 1456 millimeter square, which is coming along 1, 2, 3. So, this is how we can find out the most critical sectional area, and also we have seen that most critical section area means for different cases we have calculated, but one thing we have observed, that if we compare the connection using plain bolting or chain bolting and using zigzag bolting, the efficiency will be higher in case of zigzag bolting, that we have to keep in mind. So, when we will be going for design of some connection, we will try to prefer chain bolting zigzag bolting, because it will be more efficient than the plain bolting. That is what we have to. Now, in next class we will discuss about the strength calculation of the tension member. Now, tension member may fail due to yielding of the gross area. So, because of yielding, what will be the design strength, that we will be calculating. Next, we will calculate the rupture of the critical section, that means along critical section how it is going to fail, that we will try to calculate, and there we will see that shear lag effect will come into picture, and I told that shear lag happens when the whole sections are not connected to the member. So, if part of the member is connected, then the direct axial tension will first come to that portion, and that shear lag effect will be there in the outstanding leg, means which are not connected. So, because of shear lag effect, the strength is going to be reduced little bit. So, we have to calculate that shear lag effect, and then we have to find out the design strength due to rupture. And another scope of failure will be the block shear failure. As a whole, it may fail due to shear, which is called block shear failure. So, for that also we have to calculate how the block shear failure is going to happen and what will be the design strength. And then out of this minimum of these 3 strength will be the design strength of the member, because we will calculate the 3 cases and minimum of that will be the strength of the tension member. This is what we will learn in next class. Thank you.